Hey guys, welcome to the Level 1 Charts and Data paper from 2021. If you're joining us for the first time, the way this video works is that I go through each question and let you guys know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about answering the question. So without further ado, let's get started. So question 1A, part 1, the few things that we can talk about here, they're asking for two different features. The first feature that you could talk about is the positive relationship. And what I will do is I'll actually kind of put them in different colors so that you actually know which part I'm talking about as I start writing the statements. The overall relationship is moderate, so that's kind of like how much spread that there is. What else do we have? An outlier. So this is gonna put this as our outlier there. What else? Cluster. We've got a bit of a cluster here as well. I guess you can kind of say the cluster is somewhere there around the 2000 to, well, is it 2000 to 7000? 2000 to 7000. Yeah, I guess kind of we'll put it around here. That's still a bit more spread out there. Okay, so we've got a few things that we can actually talk about. So what I'm going to do is I will actually write down these statements. I'm going to write them down properly. So I'm going to pause the video and just write them down. And you can pretty much kind of see what I've talked about here. So it's just those kind of writing down the features of a bivariate, bivariate data right there. Cool. Let's give us a second while I type this, while I write this down. So the first kind of point that I'm talking about is number 1, which is that green line. So it's a positive relationship, which means as the number of dogs, number of registered dogs increase, the number of dog-related ACC claims increase as well. So that's describing that positive relationship. The next one we're going to be looking at is the overall relationship. So bullet point number 2 is those two pink lines. That's the strength of the relationship. Now in this case it's kind of moderate, as the points are kind of like spreading out a bit more when those number of registered dogs become bigger. So that's bullet point number 2. Bullet point number 3 is going to be talking about the outlier, which is that right here. So talking about bullet point number 3, which is the outlier, an interesting value or interesting value. Now that's at 9,000 dogs and 560 claims. One of the important thing to notice is that this is the highest value for the ACC claims, because if you think about it, the one below that is somewhere around that 500 mark. And bullet point number 4 that I'm going to be talking about is the small cluster there. So there we go. That's that blue's kind of weird looking part that I've marked out on the graph itself. And look, I don't think it'll be like you have to be exact with those cluster values. Ultimately, it is your perspective, what you see. But you definitely would not be saying that there's a cluster between 0 and 15,000, because like you can't, when I say 0 and 50,000, that's like that, but that's not really a cluster. So just keep in mind that you are kind of reasonable with that cluster. So this question here is worth a merit. So 2 features identified and interpreted is going to get you a merit grade. One of these statements is going to get you an achieved. 2 statements is going to get you a merit. Okay, so second part of the question. Now part 2 of this question, it says on the scatter graph, draw a line that best fits this relationship. Now I kind of did a rough kind of line there, but what I will do is just do that again. I'm trying to kind of get a rough idea here. Might do that, and again, this is just a rough kind of idea, right? So gone with a straight of line of best fit. What else? It says comment on the appropriateness. Now the problem with this, maybe that's, I might actually do it like this actually. Hang on. That looks more like it, but no, I'm not happy with that as well. It's terrible, right? Like when it comes to line of best fit, I always kind of go, it's like, what does it look like? That looks too little. So this is completely normal, folks, because to try and get like a best of line, and that's why it's called line of best fit, right? Like we don't really have an idea unless you do it like exactly correct. But even this one, it looks like there's more down at the bottom than, yeah, terrible. I can't believe I'm still mucking around with this. But how about that one? Does that look better? Yeah, that looks a lot better. So I don't know, just I would actually say have a pencil and just kind of go through it a couple of times to see what you're happy with. I think I'm happy with that one there. In terms of appropriateness of this model, I mean, looking at the straight line, I'm okay with this with this part here, right? Because I mean all of this looks fairly straight, but then suddenly it almost kind of like feels like it's kind of opening it up a little bit for that higher number of registered dogs. So I might just put that predictions for higher valued dogs might not be accurate. Okay, so you might have actually done this as a piecewise function. So a piecewise function is like when you do two lines, or you might actually say that this is not a straight line, that this could actually be a curve. So a curved line might be a better fit for this, but as long as you explain your decision as why you think that curved is, why do you think it actually fits that curved line. So grades wise, the actual the line of best fit with no explanation or comments to justify the decision will get you an achieved. So if you just draw like a direct red line, you're looking at an achieved grade for this, all right? But if you were to write this little statement below, then you are potentially looking at a merit for this question. Cool. Part 3 of this question next. So there's a few bullet points that we can actually talk about. The first thing is that I'm gonna have to pause and write again, so bear with me, folks. I might actually just write down all the points and then I'll talk you guys through it. Okay, so the first thing that we're going to talk about is the predictions are not useful as the strength of the relationship is moderate. Because if you think about it, remember how we talked about that line of best fit, something like this, and then that yellow part there is like how spread apart from it the data is from that line of best fit. So it might not be useful, but on the contrary, you might actually say predictions might be useful because the relationship is moderate. It's one of those questions where you can answer either, but as long as you justify it, you're pretty much good to go. One thing that we can say is for the second bullet point that I've actually said that relationship is strong for under 7,000. So if you look at under 7,000, those values are like really close together. So you can actually be quite confident with your prediction for anything under 7,000, but anything over that, that's when we're talking about the next bullet point there. So anything over 7,000, the pattern is actually more scattered, because if you look at it, it's like, there's a bit more kind of scattering happening there. It's almost like it's kind of like opening it up almost. So you've got to kind of keep that in mind. So predictions might not be useful as the number of dogs actually increase. A couple of other things that we can notice is that we were told that this was a small sample, like it was told for a sample of councils. Now, if we have a lot of councils from around New Zealand, that might actually help us be a bit more accurate with, a bit more confident with our predictions and so on. And the last point that's worth remembering is that this data is actually from 2019. So we only have like one sample, like from 1 year. And what would be beneficial is like having a few different years in there rather than just a one-off year. And particularly with over the last kind of couple of years, if you really start thinking about it, like especially if you look at since 2020, we had a lot more dogs that were at home because of COVID and whatnot, and so we don't know how that data would actually affect this and so on. So it's just to kind of keep that in mind, that if you do have like different data from different years, that might actually, it might mean it might look something completely different. So grades wise, you're looking at one statement for achieved and then two statements for merit in this question. All right, let's go to the next question. So for this question here, what we've got here is, what's the random selection, what's the probability that it's not a Chihuahua? So we've actually got 180 dogs in total. And if it's not a Chihuahua, that means every other dog. So we could actually go, well, what we need to do, go this, plus this, plus this, plus this, plus this, plus this, plus this. That's just too much work. I'm just going to go 180 minus 12, which equals to 160 out of 180. Which then the probability is going to be 168 divided by 180 is 0.9333. And if you were to do this, you will get an achieved grade. And then we shall go to the next part of this question. So for the this question here, what we're going to do is, first off, we need to actually work out what the expected number of pit bull dogs are. So we're going to actually work it out, and the way we're going to work it out is expected number of pit bull dogs, which is, we've actually got 6 American pit bull dogs out of the 180, and then we've got to multiply it with 20 because she actually saw 20 dogs. So if we were to do this, 6 out of 180 multiplied by 20, it's going to give us, now it's only giving us 0.667 as the expected number. That it's basically saying that it's less than one dog. So the first thing we're going to say is like, yes, it is very unusual. Just going to write a statement. So we're going to say that yes, it is unusual, as 6 is much higher than the expected value of 0.667. Right, so we're actually expecting less than one dog, to see less than one dog, but seeing 6, it's really unusual. So doing this, now do you agree? Now in the italics there, it says justify your answer using statistical reasons, giving at least 3 different supporting statements. So we've got to give out a few more supporting statements for this, and we're not just stopping with this question here. So we got a few things that we can actually write about. So as usual, I'll write the statements and then talk you guys through it. So there could be an error in the data collection, right? Like, I mean, for example, we don't actually know where the location of Nania's beach is. It might not be actually in Auckland, and then if she's actually going out to, say, this particular beach, and I mean, I know this, it's like I actually take my dog out for like a schnauzer walk, and what if you actually had like some people who decided that they're going to have like a pit bull meet up in the what do you call it, in the beach. If that's the case, then it could be like one of those areas where there's like people have a lot more pit bulls, or they actually had like someone coming in for one of those local walking groups. So we don't know. So that's one thing that you can talk about. I guess the next thing is that this data was actually from 2019, and once again, you can't actually make a conclusion with data just from 1 year. What if, again, this goes back to what if that particular year there just happens to be more pit bulls in that beach? So we don't know. Like, ideally, we'd need a few more years before we can kind of make that judgment or conclusion there. The next thing is sampling variability. Of course, this could have completely changed the figures, because you never know what would happen if you have like a bigger sample or a different sample. So it might not actually be true at all. And of course, you can't really make decisions based on one walk as well. So that's something else to keep in mind. Now, on the off chance that, I mean, like, we could also say, like, if she did see 6 pit bulls out of 20, 6 out of 20 is actually a probability of 0.3. Then the graph of the 180 dogs. So if we go up there, 180 dogs actually showed 6, right? If it showed 6, then what we could say is 0.3 times 180 should be 54. That means this number here, like, this should have been like 54. It's a terrible thing, but like somewhere around there, that should be 54 there and not at 6. And of course, one other thing is that, there could be an error from Nania herself, because she might not know what a pit bull looks like. So that's something to consider as well. Now, this question here, looking at what you could, there's a lot to kind of deal with. 0.0667 is going to get you an achieved, correct, expected, and a comment, unusual, and one of this is going to get you a merit. So for merit, you need the probability, you need this, and you need one statement from any of those things as to why it might, why there might be an error in the data, or that. And for E7, you need 2 of these statements, and then for E8, you need 3 of these bullet points there to get an excellence, which is worth 8 points there. All right, let's go to the next part of this question. So the first thing I'm going to do is I'm actually going to work out the probability of Jack Russell. So if you look at Jack Russell, you've got 21 out of 180. So 21 out of 180 is going to give me a probability of 0.1167. I got probability of Bichon Frise, which is 12 out of 180. So 12 out of 180 is going to equal 0.0667. Now it actually says that it's twice as likely. So what I'm going to do is I'm going to divide both of those probabilities to, so I'm going to do 0.1167 divided by 0.0667. And what is that equal to? So I'm going to get 0.116667 divided by 0.0667, and that's going to give me about 1.75. So I wouldn't, so not twice, not quite twice, like twice as likely. Not quite. Pause and write first. So as you guys can see, I mean, like, we can't really say it's not quite twice as likely, but it's actually not far off as well. So the claim is strictly not true. But the key important thing though is, remember that this is actually for the data is actually from Auckland. But if you look at the claim is actually for dogs in New Zealand, and you can't really make this claim from Auckland's data, because it just doesn't make sense there. So that's something to keep in mind. Grades wise, probability of Jack Russell or probability of Bichon Frise calculated as an achieved. So you could get achieved for this or this value. 1.7 times fine could be an achieved as well, or just a comment could be worth an achieved. But for a merit, you are going to need the 1.75 and comments talking about not as quite as likely, or you could talk about the data is actually from Auckland but the claim is for New Zealand. So that's something to keep in mind. Excellent, that's question 1. All right, so question 2, we're going to start off by looking at average number of pure breed dogs. So we're looking at that. Now we got 2 numbers that we can actually potentially write down, because which average would accurately describe. So we can say that median is 4063.5, and then the mean is 4512.8. But looking at this particular data here, like, there's this little outlier there. and that could actually have an effect on the mean. So therefore, your better option to go with in this case would be median. Yeah, so just a quick little statement, just use median as the outlier will have an effect on the mean, or you can also say median is more reliable. Again, that's because of that outlier there. Okay, next question. Got one of these 3 different key features. So the first point we're going to talk about is the center. Now you might have actually gone with the mean. If you do go with the mean, then remember to state the 2 mean values. I'm going to go with median here. The median for purebred dogs is 4063.5. It's higher than the median for crossbreed dogs, which is 2408. Now, really important that you guys state the values. Yeah, it's something that it just comes, I always forget to write the values, but for you guys, folks, you know, if you are writing it, make sure you write the values. The next one worth talking about is the shift itself. So if you look at it, the middle 50% for the purebred dogs is shifted to the right compared to the middle 50% of the crossbreed dogs. The next feature to look at is the shape itself. So if you look at the shape, both of these ones, they are, yeah, there's a bit of a right skewness, and definitely not symmetrical as well. Now we are going to talk about the spread here. So the IQR of purebred dogs is 3417. So that's taking the upper quartile and then subtracting it from the lower quartile. So we've got 5877.5 take away 2460.5. So that's where I get my 3417 from. Then I'm also going to repeat that for the crossbreed dogs. So I've got 3883 take away 963, which gives me that 2920. Now I know sometimes you might say that there's they've got a similar spread, but you might also have said that because you're looking at the spread, the IQR numerically, the purebred dogs is actually slightly greater than the crossbreed dogs. All right, last point. So the last point being is the unusual kind of like points. There is one council with both types of these dogs in large numbers, and you can see that here and here, and they register as well. So that one little council must be a lot of dogs in that area. So anyway, grades wise, it's one of these weird E7 E8 questions. It's just connected to this next question, right? So basically, one valid statement about one significant feature gets you an achieved. 2 valid statements about 2 significant features gets you a merit. 3 valid statements gets you an E7. So this is where you get that 7 points. And if you want the E8, it looks like we have to make 3 valid statements and correct climb from part 3. Okay, so the part 3 question we need to answer to get that final excellence point. But up till this point, you can actually get E7. Now, folks, I mean, if you know that, if you know me, you know that like this is only like I've only been attempting stats papers for the last kind of like month. One thing that I am noticing is that, you know, when it comes to this multivariate data, those 5 points that we talk about, the center, shift, shape, spread, unusual features, or unusual points, or whatever it is that you want to call it, they seem like a really good and easy excellence 7 points. So I mean, as I do more of these papers, I might be able to kind of give you an indication whether these are like some of those things that you must know going into a chance and data exam. But then I just realized as I speak to you that we might not actually have this next year. We might have it in a different format. So yeah, anyway, well, we'll go to part 3 of this question. See, I'm thinking this claim is actually false because there's quite a few points that I want to talk about. So let's actually write the points down and I'll talk you guys through. I guess the first thing we can talk about is the means of the 2 types vary, but purebred having Where is this at? 4,512.8, and then crossbreed at actually about 2,743.8. Now that's a huge number, you know. Even with those two kind of outliers, there's a huge difference between these two numbers. And then Reese is actually saying that it is not possible to make that claim, right? So yeah, that's bullet point number one. The next one is, so the median of purebred dogs, I can't even say it right? So we're looking at the median of purebred dogs, which is 4063.5, and then median of the crossbreed dogs, which is 2408. Now, once again, the medians also tells us that there's actually more purebred dogs than crossbreed dogs within each council. So that's another thing that's telling us that Reese's claim might be actually false. And of course, the last important point that I would say is that you can kind of say that in this sample, there's an indication that purebred dogs tend to be more than the crossbreed dogs. And the reason is because if you look at it, the median of the purebred dog compared to the median, like both of those medians are actually outside the 50%. And outside the middle 50%. So if you can actually kind of write that down in the points here. So I don't know if I'm going to make sense here, but if you look at it, let me just do it this way. So the 4063.5, which is the median of the purebred, is greater than the upper quartile of the crossbreed. The upper quartile of the crossbreed is actually here. So you can kind of see that it's more than. Then if you look at the median of the crossbreed, which is 2408, now that's actually lower than, I need a different color, lower than the 2460.5, which is the lower quartile of the purebred. So this is clearly showing us that the purebred tends to be more than the crossbreed dogs there. So grades wise, decision that a claim is false, concluding that purebred dogs with a reason based on comparison. Okay, so let's say for achieved, you got to say that it's false, and you've got to talk about, you have to have like one statement for achieved. For merit, decision that the claim is false, concluding that and with references to IQR. So for a merit, you need to say that it's false. You need to have one statement, and you need a statement about IQR. For excellence, you need to have basically false and 3 statements and correct claims. So, but again, remember that this is actually an E8, so which is a follow-up from the question 2A part 2. Oh, that's a big question. All right, on to the next one. Oh, this is a nice and simple one. To save money, they decide to have a random sample of 10. Basically, you can just say, you wouldn't be confident because the sample size is just too small. Because remember, if the smaller the sample size is, then the sampling variability is much bigger. So you cannot be confident that you can reach the same conclusion. So just going to write that down. So it's pretty much what my statement would look like. Would not be confident about conclusion being the same as sample size is too small. Second point that you want to make is that the smaller the sample size, the bigger the sampling variability is. So therefore, I would not be confident to reach the same conclusion as well. So the first statement is going to get you an achieved, where you talk about the sample size as being too small. And then the second statement is going to get you a merit, for talking about the link between sample size and the sampling variability. Okay, so next question. What's the probability that a dog selected at random from a council is purebred dog? So that's 50 out of 190. It's weird, right? Because it's like, I see these probability questions and it's like I don't even read the full question, which is terrible. I'm hoping you guys had paused the video and read the question, but anyway, so probability the dog is from the council, that's 190, that's from this council, and we're looking for a purebred dog, which happens to be 50. So we have 50 out of 190. What is that going to be? 0.2632. Part 2 of the question says, one of the male dogs was selected at random from the sample. Male dogs is a crossbreed. That's just 80. Well, so we've got one of the male dogs was selected, so altogether we've got 120 male dogs. And then the next part of the question is saying from the sample registered with the council, what's the probability that the male dog registered was a crossbreed? So crossbreed is 84. So it's 84 out of 120. 84 out of 120 gives me 0.7. Sorry, the previous question was actually worth and achieved. And the second question is actually worth a merit. Wow, that is crazy. 5 points for this question. That is insane. I'd have to say that's probably one of the easiest merit questions I've seen in ever. Alright, so part 3 of this question. I probably should make it up a light. What's the probability that 2 randomly selected dogs from the sample of dogs that were registered are both female? So we've got 190 in total. And how many female dogs do we have? We've got 70 female dogs. Okay. So my first selected dog, if it's female, and well, the female dogs from this council is going to be 70 out of 190. So it's 70 out of 190. Then my second one, because I've taken one dog away, we've got 189 dogs, and if we take away one female away, because we want to see both of them being females, there's 69 female dogs remaining. So then that's, if you think about it like this, if you think about it a probability tree, that might actually make sense. You got 70 out of 190, and then that's not a female. So in this case you've got 189 left, and then 70 is gone, so that's going to be 69. So that's pretty much what we're doing here. 70 times 69, where is my calculator? 70 times 69 divided by 190 times 189. Divided by. So that's going to give me 189, 0.1345. Okay, yeah, that's what I thought. Now, if you want to leave this in fraction, you could leave it as 23 out of 171. No working is shown as decimal. Answer must have at least 4 decimal places. Okay, so correct grade for this is going to get you a correct answer. 0.1345 is going to get you a merit. You could get achieved with just this. Writing this, you could get an achieved. Yeah, so that's pretty much it for this question. Cool. We're going to question 3 next. So question 3, question 1 is asked, part 1 is asking which year was the most money paid out by ACC for dog related injuries, which we can see it's this year. So we're going to write down in 2018, and we probably want to write down how much the answer is as well. So we're looking at somewhere there, which is around the 3,600,000. So we might say that highest, let me pause and write. So all I'm going to say there is highest amount of money paid is around 3,600,000 in 2018, and that is a straightforward achieved question. Correct answer with brief justification. I guess don't just put down 2018. You might want to put down 2018 and put the value as well. I think that's what their justification that they're talking about is. Cool. Second part of the question, I've got it here. So we've got to predict what's the thing in 2021. So I've got to use this to predict. Now this graph is a bit weird because, I mean, obviously there's a big spike and then it's dropped and then it's coming back up again. So I guess I could do something like, just gonna roughly sketch it out here. So let's say, if looking along that trend line there, that could be 2019, 2020, and then 2021. So I kind of would say somewhere below that, I don't know, anywhere between 3,000, not 3,000, geez, 3 million, no, for we'll be in 2021, probably say around under $4 million. Was it dollars? Yeah. So I'm gonna go with, I don't know, maybe $3,900,000. But the thing is, like, I'm not very confident with this prediction because, and the reason is because of this little drop here. What if we have a drop, something like that happens, especially considering, like, if you look at it from 2008 to 2009, there was a massive drop. And if I look at this picture looks almost this kind of like, could there be a drop in 2019? So that kind of makes it very difficult for me to actually predict this particular, how much was actually paid out. So yeah, it's something that I would kind of write that down as, prediction might not be accurate because the trend could actually change, like pretty much what I explained before, as it happened in 2008 and 2009. What if there's a drop in 2019? Then our prediction could be completely wrong. Grades wise, so they actually valid prediction is anywhere between 3.3 million to 4 million. We've given 3.9 million. Well, I've given 3.9 million, and of course they do need a evidence of it. So I've kind of extended that trend line with that green line there to kind of show, and then that should get you a grade of merit. There's no really achieved grade for this, which is interesting. Right, next part, with got trends and unusual features for this one, for part 3. So the first thing we're going to look at is the overall trend. Now in 2001 we had 1.4 million, and then in 2018, which we already calculated, which was 3.6 million. So we've got about approximately terrible words, 2.2 million in 18 years. So that's about 2.2 million in 18 years. 2.2 divided by 18. That's roughly 120,000 per year. So that's our overall trend there. So we're going to put down approximately 100 per year increase. So that's the overall trend. I'm just thinking about the previous question here. Like, I mean, theoretically that shouldn't be 18 years. That should actually be 17 years, because from, even if you look at the start of 2001 to start of 2018, that will be 17 years. I get a feeling, hang on, let me just count this again. Yeah, I'm looking at the answer schedule. The answer schedule is saying 18 years, but then it's kind of messed up in the second part of it when we're doing the piecewise functions. So I might be wrong in this, so if I am, please throw it in the comments. That should be 17 years, I get a feeling, and then that's probably 129. I would probably put that at 130,000 per year. Because when I look at the piecewise features, the rate of increase from 2001 to 2008. So if we look at 2001, that was 1.4 million, which we already knew. And then 2008, which was, I can't see, that's about 3.2, I think. I'm thinking around 3.25 million. So if I go 3.25 minus minus 1.4, which is that 10850,000 divided by 7. That's giving me, hang on, let me just see, I might be doing something wrong here. Nah, that looks alright. So approximately 265, I don't know, let's go 260,000 per year. And then I want to have a look at the rate of increase from 2009 to 2018. So in 2009, which was here, around 2.1, so around 2.1 million. And then 2018 was 3.6 million. So that is approximately, what have we got? 3.6 minus 2.1 is 1.5 million in 9 years. So 1.5 million. That's about 1667. So let's actually go 170,000 per year approximately. So you can kind of see that the 260,000 per year is that slope there, and then this 170,000 is that slope there. So that's the piecewise function. Next, we're going to be looking at the peaks. So maybe I should use a different color for the peak. So for the peak here, what we've got is an unusual peak at 2008, where the amount of money claimed was 3.25 million. Then, of course, we've got a trough as well. The trough in this case. And the trough is, of course, in the 2009 when the claims were approximately 2.1 million. So there's that big drop right there. That's the trough right there. So grades wise for this question, what have we got? We've got one statement is going to get you an achieved, or one feature is going to get you achieved. 2 with numerical evidence is going to get you a merit. So one statement or one feature is going to get you an achieved. 2 features with numerical evidence gets you a merit. Oh wow. 3 features with numerical evidence. So 3 with numerical evidence gets you an E7. But an E8 is when you talk about 3 numerical plus a rate of change calculated. And I think I calculated about 3 of them. Yeah, I calculated about 3 of them because I calculated 1 in the overall trend. I calculated 2 in the piecewise function, which means I'm going to get E8 for this, E8 for this question here. Okay, so going to part B of this question, which is here. There is a couple of ways in which you can answer this question, right? Like the first way you kind of answer this question is look at the steepness of the rise, especially after 2009, 10. Like let's say even if you look at after 2010. No, let's look at from 2009. So if you look at this green line is much steeper than the blue one, and even the yellow one is just like very flat. The yellow and the blue lines are almost flat, but the green line, the Auckland's one, is much more steeper. So your first kind of statement that you can talk about is let me write. So what I've written is like from 2009 to 2018, ACC claims in Auckland have been increasing at a much steeper rate. And you can see that with that green highlighted line, it's much more steeper compared to the blue one and the yellow one. And that's what I talked about. And of course, you're going to have to write a statement, therefore, a trend is likely to continue even further. Now, that's one way you could answer is by looking at the steepness of those graphs, like of those, not even saying it right, of those lines. But the other way you could say it, like let's say you're not talking about steepness, you could actually talk about the gap between the three cities in 2010 compared to, like, you know, if you look at the gap between Christchurch and Wellington, the gap has always seemed to be the same, but then the gap between Auckland and Christchurch and Wellington, it just keeps increasing. That's another thing that you can talk about if you do not want to talk about steepness. You can actually say that the gaps between Auckland and the other two cities have been widening since 2010. So grades wise, a statement about a wide gap or a statement about a steep increase gets you an achieved. And then using past evidence to predict a wider gap in the future. Using the past evidence to predict a wider gap in the future. So that's like saying at the bottom line, I would say, is therefore the trend is likely to continue even further. So that's the part where you'll be looking at for a merit. Right, so last part of this question here. Well, this one is pretty straightforward. So with this question, folks, what I would say is that, you know, first off, you've got Auckland as the largest city in New Zealand. All right, now if it's the largest city in New Zealand, you've got the largest population, and you know it's a very good chance that we've got the highest number of dogs in the entire country as well. So that means a lot of the claims that we put through in Auckland is going to have an impact compared to the other cities. You know, Auckland's got the highest claims already from what we've seen so far. Now, because Auckland has the highest proportion for the whole country, so whatever the trend in Auckland is, it's probably going to be very similar for the trend of for the whole of New Zealand as well. So it's just something that you guys can talk about. All right, now let me just write that down and then we'll sum it up. So there we go. Yeah, that's pretty much a couple of the statements that's actually worth writing. What do we've got grades wise? You know, a statement about Auckland having the greatest population and therefore the greatest number of dogs is going to get you an achieved. So right at that point there. The merit is linking Auckland having the highest proportion for the whole country, and because Auckland has set this trend, which pretty much tend to kind of dominate the trend for the whole of New Zealand as well. So making that connection is going to get you a merit. Cool, that's it for this question. Alright guys, as usual, if you do find that if any of the questions that I've done wrong, which is most likely going to happen, so feel free to drop a comment. Just if you find something faster or if you feel like I could do it in a different way. Yeah, but all I wanted to say was best of luck for your exams this coming Thursday, Wednesday, whenever it is. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.